Okay, so hopefully now you know how to find the relative max and mins on the graphing calculator. Let's say I need to double check here. So it said 0.71, 4.3 is 1. So 0.71, 4.3 is a maximum. .71, comma, what did I say it was? 4.3? I don't remember. I think it was 4.3. Okay. And then you have a relative minimum at 3.3, comma, negative 4.3. And that's what that minimum is. Now, since this is a maximum, and this point is these x values here are to the left of this x value, we know that it is increasing from negative infinity to 0.71. We know it's increasing, and this is an interval. This is not a point. This is on this interval. When we're talking about these intervals, we're only talking about domain. So this is domain only. That's domain only. So it is increasing from there to there. And now it changes direction at the maximum. It turns and it starts to decrease. So it's decreasing from the interval of 0.71. And it decreases to the minimum x value of 3.3. So that's where the x value has its lowest value. That makes it a minimum. And then it changes direction again and starts to increase. So we have to union that together with the other increasing interval, which starts at 3.3 and goes out to infinity. So we have to union those two together. So there's two areas of increase, one area of decrease on the graph, and that is clearly shown on the graph, right? So from negative infinity, way over here, as I move on the x to the from the left to right, we are actually increasing to this point where the maximum is, and then it changes direction, and now we start to decrease for these x values to 3.3. And then it changes direction and starts to increase. So it's on an increasing interval. So these x values are increasing. These x values in between the max and the min are decreasing. That is a decreasing interval. All right. So we will be able to use that information to help us graph a function. So we're going to go ahead and graph this function. You can put this function in your calculator, and you'll find out that you have a minimum right here at 0, 0. I believe the maximum was at 1, 4. So let me go ahead and sketch that in there. Let's get this off there. Sketch this in. 1, 2, 3, 4. And then at 3, there was another point where it crosses the x-axis. Okay, so I know that's where that is. Now, domain for these, just like quadratic, the domain for these are all real. So from negative infinity to infinity, we're using all the x value inputs. And a range for this, since it is an odd function, it has that funny shape that goes like this and like this. It goes on forever down and forever up. So this is also from negative infinity to infinity. If it was an even function, it would turn. You would have somewhere you would have a max or min, and it would not go to infinity on an even function. But since this one is odd, it is negative infinity to infinity. Okay. So our relative maximum, I think you put that on the calculator, I believe you'd come out with 1,4 roughly. Okay, the relative minimums are going to be at 0, 0. So that is the relative minimum. Now we could talk about end behavior, which is also going to help me graph this or get a sketch. I'm not too worried about like being very precise. I just need to know what it kind of looks like. Okay, so in behavior, we talked about this. We have a leading coefficient that is negative. So that means this side is going to be going down, and it is odd, which means that this side is increasing to infinity or going out to infinity. So my sketch is going to come down and hit my turn, and then cross through and go down and out. Okay, so I know that from the end behavior, as on the right hand side, since it is a negative leading coefficient, this is going to be negative infinity. Now it's an odd function, which means that this needs to go in the opposite direction, as I showed on the graph, so that goes to infinity. I know this is a relative minimum, so for my x values from negative infinity up to 0, 0 right here, this is all decreasing back here, all decreasing. And then if we look at it again, it starts to decrease from our max. Going out to infinity is a decrease. And in between those 2 points, we have an increasing interval. So, for our intervals, from negative infinity to 0, that is a decreasing interval. That's the first part of the journey here. Boom, it turns directions there and goes from 0 to 1 right here at the maximum, changes direction and starts to decrease. So I got to union this together. It's decreasing from 1 to infinity. Okay. So that's everything, and that helps me get a sketch of what that graph would be like. It doesn't have to be perfect. All right, we just kind of need to know where those changing points are. We'll figure out where it crosses the x-axis, where it crosses the y-axis a little bit later, but that will give us a sketch, and that should allow you to do the next 3 on the next page, and I will see you in class on Thursday.